Can all of you hear me, guys? Yes or no, please tell me.
Yes, sir.
In the last class, we looked at different method of preparation from alkene. One of the method of preparation, it was using just halogen, that means Cl2 Br2. In that we got vicinal dihalides, and then we saw when what happens when we use halogen acid or halo acids. Now, when we use HCl, HI, HBr, in those cases we have two situations: in the presence of light and peroxide, or in the absence of light and peroxide. In the absence of light and peroxide, we use Markovnikov rule, and in the presence, we use anti-Markovnikov rules. Okay. Today, we are going to learn about before going there, I think we should write the rate of reactions. Okay, please write. Write a note. Rate of reaction of alkene plus HX, any halo acids. So if you're talking about HX, then in that case, HF will be least fastest. Then you will have HCl. Then you will have HBr. Then you will have HI. Now, HI is fastest because the bond between hydrogen and iodine is very weak, and that is why they can dissociate very easily. From here, we have three more reactions to learn, and all of these three reactions are named reaction. The first one we will do, and you can do it. You can remember this as one section, that is known as halogen exchange method. So in halogen exchange, there are two reactions which occurs that come into the category of halogen exchange. No, in halogen exchange, first one is Finkelstein. Yeah. In halogen exchange, we have first, which is known as Finkelstein. Finkelstein reaction, and the other one is known as Swartz reaction. Now, in Finkelstein reaction, we used Rx. Now, this X can be either chlorine or bromine. And then we use sodium iodide. Now, when we use sodium iodide, we cannot use water as a solvent, because when sodium ion they get into contact with water, there is a lot of heat exchange. That is why we use dry acetone. Now, when you see this word dry acetone or dry anything in chemistry, don't think that it is going to be gaseous in nature or solid in nature. Acetone is liquid, but when we say dry, in chemistry, dry means absence of water. So anhydrous also means absence of water. Dry also means absence of water. So dry acetone just means that it is absence of water. And obviously, dry acetone has nothing to do with the reaction. Okay, it is just providing a surface for the reaction. Wahan reaction ho rahi hai. The reaction is happening there. Okay, so in the presence of dry acetone, we are going to get Ri, alkyl iodine, plus we will get Ne, and whatever halogen we are using, NaX. Now, in Swartz reaction, what can happen? We are going to use Rx. Now, this Rx is also same thing. X will be chlorine or bromine. So what is happening? You can see one halogen, chlorine or bromine, is getting exchanged by iodine. Okay, so that Cl and Br is being replaced by I. That is why it is halogen exchange. In Schwarz reaction Rx, it is reacted with any metal fluoride. So for metal fluoride, I will write MF, but please remember that MF is not a reactant. Okay, it is not a reagent. This is a generalized form for writing metal fluoride, and we are going to get RF, alkyl fluoride, plus a metal halide. Okay, so RF is important. What are the metal fluorides that we can use? The metal fluorides that we can use are silver fluoride or Hg2F2, mercuric fluoride. Okay, you can use antimony fluoride also. So all of these meant any, if you see fluoride, then obviously you are going to add what? Fluorine here. Okay, you are going to add fluorine. And if you are seeing that one chlorine or bromine is getting exchanged by fluorine, then that is a Schwarz reaction. Now what is happening here? Chlorine or bromine is replaced by iodine. And what is happening here? Chlorine or bromine is replaced by fluorine. All of you understood this? Yes or no? Finkelstein and Schwarz reaction. Tell me, guys. All of you understood this?
Yes, sir.
Okay. Now you can do some problems here, simple problems. Now, please remember when I write these simple problems, don't think that in exam they will be asking you in a like exact way. No, they will not they will not ask you in exact way. For example, if I give something like this, Br plus sodium iodide, and this is I'm writing Da, that is dry acetone. Huh? So see, there are number of ways in which they can ask this question. Now, the same information can be asked. What happens if ethyl bromide reacts with sodium iodide? Now, obviously, if you have a bit of understanding about structure, then you can understand, okay, fine, this question was done in the classwork, right? So when sodium bromide is reacted with, when ethyl bromide is reacted with sodium iodide, we will get ethyl iodide. That should be your answer. Or even if you show this reaction, that is enough. Okay. Now, it doesn't matter if you write this NABR or if you don't write this NABR. In all the marking schemes that CBSE provides, I have seen that this byproduct doesn't matter in the marking scheme. Okay. So if you write it or you don't write it, that doesn't matter. Okay. Now, let me give you some other problems. All of you understood this? Yes or no? Please tell me. Right. Other way of asking this is they will ask you, how will you convert ethyl? Let me take another slide. Another reaction. How will you convert one bromocyclopropane, or they will ask you, how will you convert cyclopropyl bromide to cyclopropyl iodide? They can give a blank on the reagent sign. Then you should know that what we have to use, we have to use sodium iodide in the presence of dry acetone. So if you see, all of these questions are asking about Finkelstein, just the way of putting question is just a bit different. It's not very different. All of you got this? Yes or no? Please tell me.
Yes, sir.
Write some other problems. So take 2 minutes and then send the answers on my WhatsApp. Well, don't take more than 2 minutes. Yes, Mariam, just a question on the second number, that Br and sodium iodide. I can see in the product you have, it seems like there is a double bond, but that's just a writing mistake, right? You don't mean a double bond. Okay. 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 Thanks. So here we will get fluorine. Here we will get sorry, not the benzene ring, my bad. Here we will get fluorine, and here also you will get iodine. Yes, Pia, I think your answers are also correct. Yeah, very good, Hafsa. Yeah, your answers, those are fine.
Sir,
Yeah,
can
tell
you
me.
just scroll up, sir? Because first I did not write the part note rate of reaction of.
Okay, okay. Take a screenshot.
Uh,
Took a screenshot.
yes, sir. Finished.
Now, the next reaction is very important, and this reaction you will see many a times. You will see this in alcohol chapter also. You will see this uh, in aldehyde chapter and amines chapter for sure. Okay. So this reaction is known as Sandmeyer reaction. You will not exactly see the Sandmeyer reaction, but the first part of Sandmeyer reaction. What is Sandmeyer reaction? First of all, it is used for the preparation of it is used for the preparation of halogens. Okay. Now, what is the reaction? first of all, you are going to prepare benzene disonium salt. And how to prepare benzene? Now, let me show you what is the reaction, and then you will see the details. Okay. So this is benzene disonium salt. N2 positive. Cl negative. Now, instead of Cl, you can have any other. You can have any other bromide or iodide also, but generally we have Cl negative. Now, when you react this with Cu2Cl2 or Cu2Br2, I'm writing Cu2X2. X will be equal to chlorine. X will be equal to chlorine or bromine. Then what happens? Then the disonium part, N2 plus Cl negative, that is replaced by bromine or chlorine. So here you will get X. So for example, now the problem with this benzene disonium salt is it is very unstable. Okay, it is very unstable at room temperature. That is why you cannot keep it as a reagent in the lab. Okay, so in the lab, if you go, you can see nitric acid, you can see hydrochloric acid, you can see many other things, right? Many other reagents, but you will not see benzene disonium chloride. Now, the reason why you are not going to see benzene disonium chloride is because it is not stable at room temperature. Now, if it is not stable at room temperature, then how are we going to use this as a reagent? Then we use a method that is known as preparation in situ. What is preparation in situ? That we take reagents which are going to give you benzene disonium salt when reacted, and after that we will write, just we are going to add the next reagent. So how this happens, please write. First of all, write a note, and then you will write, this is note से पहले यहाँ पे आप लिख लीजिए that this is benzene disonium chloride, or instead of chloride, you can also write salt. Okay, and we call this BDS, benzene disonium salt. So like BDS is unstable at room temperature. Therefore, it is prepared in situ. In situ means between a reaction. Okay. Is everyone having problem in listening my voice? Rabia, Rabah, Khatun, tell me. I'm audible properly,
sir.
na?
Yes, sir.
Yeah, maybe plug in earphones or something. Or in your laptop, the volume must be low. That is why you cannot hear. Okay. So in benzene disonium salt, it is unstable at room temperature. Therefore, it is prepared in situ. Therefore, it is prepared in situ. How do we prepare it? We take benzene attached with NH2 and we call that as aniline. When benzene is attached with NH2, this is known as aniline. Aniline is reacted with NaNO2 plus HCl. Now, NaNO2 and HCl, it gives you ONO. What is ONO? ONO is ONO. ONO, nitrous acid. Okay. So it gives you nitrous acid. And obviously, this is prepared at very low temperature, 0 to 5 degrees Celsius. 0 to 5 degrees Celsius. Now, when it is reacted, then we get benzene disonium chloride. Then we get benzene disonium chloride. Okay. Now, after this, what we can do, we can react this with Cu2Br2 or Cu2Cl2. So this is how benzene disonium salt is prepared. All of you got this? Yes or no, please tell me.
Sir, what is after prepared in?
What is after? In situ.
Prepared in.
Prepared in situ. It means between a reaction. So when we want to do reaction, so at that time only we prepare benzene disonium chloride. That means we do not keep it in shelves and we do not keep it in lab. Whenever we want it, we prepare it. So in situ.
So that means it's SITU.
SITU. So wherever it is required. Okay. So in situ means in the reaction mixture. So wherever you want in situ preparation means in reaction mixture. Okay. Right, next point. Heating benzene diazonium chloride or benzene diazonium salt with Ki forms iodobenzene. Okay, forms iodobenzene. But please remember, but this is not Sandmeyer reaction. But this is not Sandmeyer reaction. Okay, so our Sandmeyer reaction, the reagent is what? Cu2, Cl2, Cu2, Br2. These are the only two reagents in Sandmeyer reaction. So what will happen? We did not write benzene diazonium. When you have benzene diazonium chloride and you treat it with potassium iodide with some heat. Now, if you see potassium iodide, then you can also use sodium iodide. Okay, so that much chemistry you NCERT and everyone expects from you, that potassium iodide, sodium iodide, they will have similar properties, right? That is why you can write both of them. This is going to give you iodobenzene like this. You write this down. Done, everyone? All of you wrote this?
Done, sir.
Okay. Now, right now you have write this last two remarks, and then the method of preparation will be completed. Now, this remark is in general for all the method of preparation. Just let me reopen this thing. It's very glitchy right now. Yeah, please write. Number one, if you saw in all the reactions, we never reacted anything with Cl2 or I2. Sorry, we did not react anything with F2 or I2. Fluorination and iodination is not done directly. Okay, so we have to write the reasons for that. Why do we don't do it? Please write. Fluorination Fluorination means reaction with F2 is not done in the preparation of, is not done in the preparation of fluoroalkenes. Because F2 is highly reactive. Because F2 is highly reactive, therefore reaction gets highly violent. If something is very reactive, then what is going to happen? It is going to liberate a lot of heat, right? It is going to liberate a lot of heat. It will be highly exothermic and it will be violent, which cannot be controlled. Which cannot be controlled. Now, those who know the structure of fluorine, and if they remember anything from the chemical bonding chapter of class 11, then they should remember that fluorine has a structure with a single bond fluorine, and it has 1, 2, 3 lone pairs, 1, 2, 3 lone pairs on each fluorine. Now, because of these lone pair electrons, both of this bond is very weak and it can be broken quite easily. Fluorine-fluorine bond. Okay, and when both of these break, it liberates a lot of energy. Okay, when they are going to break and form a new bond, it's going to liberate a lot of energy. That is why it is highly violent. Now, write the next point. Similar is the case, not similar, but for completely opposite reasons, we don't do iodination. Please write iodination. Reaction with I2 is not done for the preparation of iodoalkenes. Because I2 is unreactive and very slow. Now, if you understood this, yes or no, please tell me.
Yes, sir.
Now, this method of preparation of haloalkene is complete. अब आपका काम start होता है, ठीक है? Now you have to start working on how to revise things and how to memorize these things. So the best way to do this is making reaction maps. Okay. There are a few things that you need to ace organic chemistry. And one of the very initial things that we have already done is nomenclature. If you don't have a clarity on nomenclature, if you cannot switch from structure to name and name to structure, then you are always going to be stuck. And the more you get stuck in these things, the more it will take time, and then you will be bored with organic chemistry. The thing is that we have to cover a lot of things in very less time. That means we have to be able to switch from name to structure and structure to name very efficient. Next thing that you know, and we have also covered that, is the bond line structure. Now, what bond line structure does, it does not increase the your, what can I say, organic chemistry knowledge. It just saves you time, and that was the reason for bond line structure, that it will save you time. Now, main thing for organic, you have to learn a lot of things in a very less time. So in order to do a lot of things in very less time, we have to know bond line structure so that we can practice as many questions as we want. Okay. Now, the next thing that you should have at hand right now is reaction maps. So what is a reaction map? You will take a single sheet of paper, one A4 size sheet, and in that you are going to summarize all the method of preparation of We're going to summarize all the method of preparation of haloalkenes. Now, how you do it is going to be your choice. Now, the only thing that I can suggest is don't copy from internet. Okay, don't copy from internet. What you should use is my notes. And if you want to use anything extra is NCERT. Okay, nothing else. Which or you don't have to use anything else. Now, I will classify the method of preparation. My classification would be, first of all, we did alcohols. Now, in alcohols, we saw phosphorus-based reagents, right? Then we saw SOCl2. Now, in phosphorus-based reagent, there was nothing to be catchy. There was no why questions there. But for SOCl2, there was why question, so I will put up a star. This has some why question. What was the why question for SOCl2? Whenever you have all of these things at hand, I mean, you have to make links. Okay, everything is related, so you have to make links. What was the why question? Why is this a preferred method of preparation for haloalkane and for haloalkanes? The reason is the byproducts are escapable gases, and we don't have to purify the haloalkane that we get. Okay, so you will put up a star here. Then see, this is present in your notes itself. Thank you, right? Why is the use? So when you are going to use the notes, then you will see everything. But the difficulty with NCERT is going to be you cannot read you are not going to read the complete NCERT. You know? And NCERT doesn't come in a highlighted order. That the important things and the questions, all of these things are highlighted. So you have to read complete NCERT, and this is there in NCERT. I'm not saying it's not there, but it is between the lines. And most of the students, when they are going to read the reaction, they will just see the structures and the reaction. Wherever the reaction, yeah, reaction, here another reaction, here another reaction. Okay, so take NCERT with you, no problem. But please have my notes with you. Okay, if you have the notes, then only you will be making good short notes. Okay, now what is the next thing you are going to do? SOCl2, then we have NaBr plus H2SO4. Now, this also has a why question. Why we can't do similar thing with sodium or potassium iodide? Okay, so here you have star question, and then you will see NaI plus H2SO4. This cannot be done. Why is the question? Okay, then we have HCl plus ZnCl2. Important thing is here the reactivity. The reactivity of 3 degrees greater than 2 degrees greater than 1 degree. Although we are going to do this once again in alcohol chapters. Then we have from alkenes. In alkenes, we have only one, that is free radical halogenation. Now here the concept of isomers is very important, so you will revise isomers here. Then we have from alkenes. Now in alkenes, you have two methods. When you react with halogenation, if you do X2 plus Cl2 Br2, then you will get vicinal dihalides. Then we use HX. Now HX can be used on its own. So here you have two cases, Markovnikov or anti-Markovnikov. Markovnikov addition or anti-Markovnikov addition. Markovnikov rule or anti-Markovnikov rule. After that, you can put the rest of them in miscellaneous. What are the miscellaneous? Miscellaneous is number one, electrophilic aromatic substitution. Then the next one is Sandmeyer. And then the next one is halogen exchange that we just did. So in halogen exchange, you will have fluorine and you have two things. You have Finkelstein reaction and you have Schwarz reaction. Now, what I suggest you to do is you write Finkelstein and Schwarz and you write F here. That means in Schwarz reaction, you are going to get fluoroalkynes. And so in Schwarz reaction, what happens? You will have halogen and it will be replaced by fluorine. And what will happen in Finkelstein? You will have halogen, it will be replaced by iodine. Okay, so this is how you summarize things, but you are not going to write it like this. You are going to write the complete reactions. Okay, so you will start like this. In a single sheet now, you have to write like this. RCH2OH. Okay, SOCl2. Then you will write PBr3 and PF3, all of these things. Then you will write NaBr and H2SO4, all of these things. Then you will write something like this. Make RCH. Here you have double bond like this. Huh? Then for this you have two methods. You have here HX. All of these things are going to give you what? X. You write it like this, X. Okay. Then you have HX, and then you have HX in the presence of light, or you will write helper, right? So helper is going, this is going to give you X here, R is going to be here, and this is going to give you R is going to be here, X here, right? So this is the way how you are going to summarize it in one page. Now, since we are done with this, what I would suggest is, and I will leave the class a bit earlier today because I want to give you guys time to first of all write. Now, when you are going to try to summarize things, then you will find it a bit difficult to summarize it in one page. So it will take you 2 times to summarize. Once it will be in like 2 pages, maybe you can summarize all the reactions. Write it in a bit of small font. You just need to need this for revision. Okay. Then in the next phase, what you will do, you will sit with those 2 pages, and then you want to summarize it in 1 page. Now, this is your revision. Okay, this is your revision. That's it. You don't have to revise anything else. What you need to do, you need to make short notes. That's it. Once you have done the revision of the method of preparation, what you need to do next is you need to make a sheet of haloalkene halorine that will contain Y questions. So we have seen many Y questions. If I start from here, do we have any Y? I don't think we have a Y question in the first class. Or wherever you see because, that is a Y question, which can come in both the cases, in the case of your assertion reason also, and in the case of your simple questions also. For example, thionyl chloride is a preferred method of preparation of haloalkane, that is assertion. And the reason is given that because the byproducts are liquid or aqueous. So that is the wrong reason, right? So whenever you have because question, you write the question only. You will write the question only. You will not write the answer. Your answer should be in the brain. Okay, your answer should be in the brain. But as soon as you see the question, you should be able to answer it. But please remember, these are for revision. Okay, these are for revision. So you have to read the notes and then look at these particular short notes, and you will see why question like this here, right? Then next is, we have any Y question. This is another Y question. Why potassium iodide or sodium iodide is not used? So you see the word here because. So wherever you see because, that can become a Y question. All of you understanding what I'm trying to say? Yes or no? Please tell me.
Yes, sir.
Okay. Then next you will see. Now again, this is a Y question. Because is here, right? So this is how when people say everything comes from NCERT. All of my notes are also from NCERT. Nothing from sorry, nothing is from anywhere else. It's just that when a teacher teaches, he knows the questions also and he knows the text also. In NCERT, the problem is NCERT is not a book that should be studied alone. It should be either studied with a teacher, or it should be studied with some other book, but preferably with a teacher. So when you will see that many of the questions in NCERT textbook, they are such that they have to use some of the knowledge from class 11. And even if you will see this thing in the NCERT, we have studied this in class 11. They don't repeat things. Okay, they don't repeat. They say that you have read this in class 11. Now teacher has to repeat those things in front of the students. See, we have done this. For example, isomers are not a part of haloalkane halorine, but we have to teach isomers because unless and until you know isomers, you will not be able to understand about the number of products that can be formed when we are doing free radical halogenation. Okay. Now see, this is another because why phenols cannot be used for preparation of halorines in this case. So this is another question. You'll form the question now. You have these answers in your note, and you are going to form the questions. Okay. Then again, here you will see a Y question. Free radical halogenation is not a suitable method for preparation as we get, because we get, right? Same thing, right? So this is another Y question which can be asked. Then here you can, Y should be, Y is excess of alkene taken to get monohalogenated product. Okay, so all of these are simple Y questions that can come. Then next you'll see this. This is how you are going to do things. That means you will see each day's note and then you will identify what was the why question. Do you have any? This is free radical halogenation question. Now, rate of free radical halogen depends on the stability of carbon free radical. So if they ask why is the rate, that is, I mean, why tertiary butyl is going to, sorry, why tertiary butyl bromide or why tertiary butane, why tertiary butane is going to react fastly rather than secondary butane, okay, normal butane, then you are going to write because the stability of carbon free radical is like this, like this, like this. So all of these are different questions that can be. So identify the alkane inverse. So this can also be asked in a why question. Why neopentane gives only monochloro product? Then you are right, because there are only one type of carbon atoms with hydrogen. Okay, so these are the things. So what I said, you will make a sheet of why questions. This why question will contain only haloalkane and halorine. So all the why questions, see, we have done only what? Method of preparation of haloalkane, halorine. And you have all of you guys, please tell me, you are seeing this complete thing as cases of reactions only, right? Yes or no? Tell me, Rabia, Rabah, Tarif, Mariam, Hafsa, Fia. What was in your brain? Reactions will come, right? Yes or no?
Yes, sir.
But can you see that there are theoretical questions which can be prepared from the same thing that we have done in these days? Theoretical, pure theory, without any structure also. Right? So now this is haloalkane halorine. I take a lot of time in haloalkane halorine just to develop the mindset for organic chemistry. Okay, so we'll prepare a sheet of why question till now, whatever we have done. Now, once you are done with today's class and you have a sheet of why questions, in the next class, what you have to do, now you understand. In the next class, when the class is done, you will sit with the notes that I have given, the class notes, and then you will take out the why question paper, and then you will read the notes and you will try to identify where is the why question. If you see any word due to, if you see any word like because, if you see because we do this and something like that, I hope you have that that much of sense you can make. Okay, fine. This can come as a why question. Okay, so you will note that why question. You will prepare this why question sheet for each and every chapter. Halogen, halorine, alcohol, phenol, ether, aldehyde, ketone, carboxylic acid, amines. So you have halogen, halorine, alcohol, aldehyde, and amines, right? So that is going to be 5 pages. Okay. So you will start with the why question for halogen, halorine. Now, another thing, that is 1 page you have to make. So 5 pages, and then you will have, this is for why questions. Then for method of preparation, 5 pages. Okay, you will have only 4 pages now. Alcohol, sorry, halogen, halorine, alcohol, phenol, aldehyde, and amines. You will have only 4 pages. So this is the 4 pages for why questions. Then you will have method of preparation of alcohol, phenols, and ether. So that will take around 1 to 1 pages, I would say 1 page. Okay. Aldehyde and ketone and carboxylic acid, that takes 2 pages because number of preparation of aldehyde and ketone is a lot larger. That is going to take you guys 2 pages. Fine. So for that 2 pages, 2, 4, and then 5 pages. You will have 5 pages that will be having method of preparation for different things, right? Halogen, halorine, one page. Alcohol, phenol, ethers, 1 page. Aldehyde, ketone, carboxylic acid, 2 pages. Then amines, 1 page. So 5 pages you will be requiring for method of preparation. Then there will be around 5 to 6 pages of chemical properties. 5 to 6 pages of chemical properties. Okay, in that you will list out, okay, haloalkane gives this reaction. Again, similar to this way. Okay, you have to make spider map. Okay, for reaction map you have to. Once you are done with the chemical properties, then 1 page you are going to require for all the chapter, where you will write chapter wise name reaction. So as you saw that we have done chapter-wise name reaction, where chapter-wise name reaction we did the Sandmeyer reaction, right? Halogenation, Fincasine, and Swartz. So what you are going to do, you will take a sheet of paper like this, one A4 size paper. You will write the heading. Now, one more thing that you need to do is you need to divide this A4 sheet paper into two parts like this. Okay. Then you will write haloalkane, halorine. Number one, you will write Sandmeyer. Now, you will just write Sandmeyer, you are not going to write the reaction. Why you are not going to write, sir? Why not reaction? Because you will write MOP. What is the meaning? That means if you want to remember the Sandmeyer, the thing is that Sandmeyer reaction should be there in your head. Sandmeyer reaction should be not there in your copy. The best place for Sandmeyer reaction is in your head. Okay. But let us suppose you don't remember the Sandmeyer reaction. Then will you go to NCERT? Will you go to my notes? No. Where you will go? You will write in bracket MOP. That means you have to refer to what? The MOP page. You will refer the MOP page of haloalkane, halorine, and then you will see there what you will see there Sandmeyer reaction. Is this clear? Yes or no? Please tell me. Now later on, when we are going to study, you are also going to study another reaction that is known as Wood's reaction. That is a new reaction in this chapter itself. Okay, so Wood's reaction is going to be, you will write CP. CP means chemical property. So if you forget the Wood's reaction, then you will not go to NCERT, you will not go to my notes, you will go to the 5-6 pages. In that you must have written the haloalkane, halorine. So you will go to that haloalkane, halorine, and you will find the Wood's reaction. Is that understood? Yes or no? Please tell me. All of you guys tell me. Rabia, Rabah, Tarif, Mariam Khatun, Hafsa, and Fia. Is it clear?
Yes, sir.
Okay. So then you need what? One page for chapter-wise name reaction. Then you require one last page. One last page that will include all the chemical tests. That is for chemical test. For example, we did one chemical test. Okay. And maybe you don't remember. We did one chemical test, which was with bromine water. Bromination is used for test of unsaturation, right? To distinguish. So if you react with alkene, decolorizes bromine water. So all of these information is giving you about a chemical test. So you will also do this chapter-wise chemical test on whatever you have learned. Chapter-wise chemical test. So you will just write test for alkene. That's it. Bromine water. That's it. You are going to write. So one page you can include in all the 1 or 2 pages maximum. You are going to include all the chemical tests from chapter haloalkane, halorine to amines. 1 to 2 pages. Okay, 1 to 2 pages maximum. So if you count here, the maximum pages you are going to require for organic chemistry is you will have 6 plus 4, that is 10, plus 5, that is 15, 16, and 17, 18 pages. So in 18 to 20 pages, I'm taking even maximum. 18 to 20. I've taken the maximum numbers, and then after that also I'm increasing. In 18 to 20 pages, I'm not seeing sheets. In one sheet, there are 2 pages. Okay, so I'm saying 18 to 20 pages, that means in 10 sheets, you should have complete organic chemistry. Is that clear? Yes or no? Please tell me. Is it clear? Yes or no? Please tell me, guys. In 18 to 20 pages, complete organic chemistry should be there. And then if you do this, now my guarantee is you will not score less than 90 in chemistry. Many students in the last year, almost every student out of every 4 students, 1 student in my batch, they score above 90%. Okay. The ratio is quite high. If you look at these statistics of the CBSE, I think I may have the statistics of, I don't know if I downloaded it or not. So CBSE, they release statistics like how many of the percentage, how many people they scored more than 90%. But they do not do it with streams, arts, science, and so on. So around 9%, this is the average. Okay, this is the average, complete average. 9% students, they score more than 90%. They score more than 90%. Now, this ratio in my batch is 25%. And the students, many students, they scored 90%, but all the students who made this, they scored 90%. Okay, so if you want to be in the sureties, I'm not saying that if